Good morning, students. How are y'all? So we're going to go over Chapter 4, Chemistry Solutions and Molarity. Okay, your vocabulary is already up. Go ahead and do that. But I want to talk to you for a minute about how I take notes. And there's a couple of words I'm going to go over with you and explanations because I did an elements class last year with some of my students, and those students are already on top of it. Okay, so this for the students that don't understand what I learned or taught about the elements in the periodic table, we're going to talk a little bit about that today. I'm also going to have an app that I want y'all to download that'll help you to get familiar with your periodic table. But first, we're going to talk about the Chapter 4. So there's only this page, and this page to Chapter 4. The page after that is our laboratory. Okay, we're not going to do that yet. We're going to do that at school on Thursday. But I want you to be successful this week. So we're going to go ahead and go through this together today. I'm going to do the first couple of paragraphs with you, and then I want you to go ahead and take what I'm teaching you and put that into practice for the next couple of paragraphs. Okay, so first off, we're going to go over this first paragraph. Another very common method of indicating the solution concentration in a chemistry lab is the molarity. When using molarity, you are indicating how many molecules of solute there are in a liter of solution. Okay, so let's stop there. We're going to stop right here. Now, even though I've already done the vocabulary over here on the JunoPod, I'm going to take notes with this first paragraph. In each paragraph, I'm going to make a note about what I remember and what I'm learning from it. So I would write this first sentence down. When using molarity, you are indicating or stating how many molecules of solute there are in a liter of solution. And I would also make a note of what solute is. So you remember in class yesterday, the solute was the salt or the NaCl. Okay? The solvent was the water or the H2O. Okay, so do you remember that? I would make that note in this first paragraph so that I could put those memories together. So when using molarity, you're indicating how many molecules of solute another word for that is like the salt or the sugar that we used, there are in a liter of solution. Now we're going to talk about molecules for a minute, okay? And we're going to start at the very bottom of what a molecule is. And you can write this down. We're going to start with atoms. Atom is the smallest unit of matter that can be identified as an element. Okay? Matter makes up everything that we touch, see, smell, experience. The things we don't see are the oxygen that we're breathing, or the carbon dioxide coming out of a car, or everything is made up of matter in our universe. There's not a space that doesn't have some sort of matter in it. It is completely filled up with matter, okay? And what atoms are is the smallest unit of that matter. Okay, an element is the identity. Now they're identifying. An element is the identity of an atom, such as hydrogen, carbon, or iron. And if you go to the back of your book, there is a periodic table. And the periodic table is all the chemical elements that we know of so far in our universe. This is all we know so far. Okay? This is a list of each element. Okay, so our water's made up of 2 hydrogen and 1 oxygen atom. Okay? And right up here is a bar. At the top of every atom, every element, there's a bar. And this map tells what that bar stands for. So hydrogen, according to this map, is a gas. And in the corner of that red bar is its atomic number. Okay? And then down here is its atomic mass. It has an atomic mass of 1.007. Now, our water also makes up of another element called oxygen. And oxygen is also a gas, and it has an atomic number of 8, but its atomic mass is 15.99, and they usually round that up to 16, okay? So that's what our elements are. Our elements are the different chemicals in our universe, in our area. Okay, and what a molecule is it's two or more atoms bonded together, such as water, which is H2O. So a molecule is 2 hydrogen and 1 oxygen. And we're going to talk about that for a minute. Let's go back to that first paragraph and recognize what we're reading. So when using molarity, you are indicating how many molecules of solute there are in a liter of solution. And you remember what the molecule for salt was yesterday? It was NaCl. And there's no other numbers in there, so it's 1 sodium. You see that? And 1 chlorine. NaCl. So that's the molecule for salt. That's the solute that we used making our solution yesterday. So you can write that down in your notes. Remembering what we did yesterday helps you to understand this paragraph for today. So when using molarity, you are indicating how many molecules of solute there are in 1 liter of solution. The percent concentration does not give the number of molecules of solute in your solution, of course. As you realize, you cannot count the number of sugar molecules. You can, however, count the number of sugar molecules that you place in a solution if you do a lot of them at one time. And let's look at, if you do a lot at one time, what did we do yesterday to our scales with our weighing boat? We measured the salt. The solute we measured in grams. So you can even make you a little note in with that one sentence, remembering, however, you can't count the number of sugar molecules that you place in a solution, but if you do a lot of them, you can. And we did that with the salt in the weighing boat. Okay, now let's move on to the second paragraph. So you got your first paragraph of notes talking about molarity, remembering what molecules and solute are. Okay, remembering how we weighed them out in the weighing boat. You move on to the second paragraph. A rather clever way of counting molecules involves the use of what's called Avogadro's number. This is going to be hard for me. This is a little like a dozen, but it's much larger. Okay, so it's okay to count out a dozen bananas or donuts, but a dozen molecules, because they are simply too small. And there's so many of them, y'all. This is where Avogadro's number comes in handy. Just as a dozen is 12, Avogadro's number is 6.022 times 10 to the 23rd power. And this is what that number looks like. Now listen to this, guys. This really blew my mind. So, the number is so large that this many kernels of unpopped popcorn would cover the United States at a depth of 9 miles. So that means if you poured kernels of popcorn over the entire country, and I mean it would cover us, it would be 9 miles tall. Our houses would be covered, our trees would be covered, our mountains would be covered. It would be covered for 9 miles with popcorn kernels. That's how big this number is. Look, this is hundreds, this is thousands, this is millions, this is billions, this is trillions, and so on and so on and so on. This number's huge, y'all. It's incredible how big this number is. And so this number is written in a smaller way, and it's called Avogadro's number, and it's 6.022 times 10 to the 23rd power. So how would you take notes on this second paragraph? What would you say to remember that Avogadro's number is like a dozen but much larger number? Go ahead and write this big number down. And write down exactly what his number is. Avogadro's number is at 6.022 times 10 to the 23rd power. Now, how this is going to be used in math isn't written in this paragraph yet. And it's okay that it's not, because when we go to the next paragraph, it's going to explain it better. So don't get caught up in the, I just don't understand. Don't get caught up in the, this doesn't make sense to me. Only think about what's in front of you. Don't think about what you don't know. Think about only what you just learned. That keeps your mind focused, and it allows you to glean from this paragraph. Now look, we've only been doing this 10 minutes and we've gotten through 2 of the 4 paragraphs. And it's a lot of me talking. But if you did this by yourself, this would have been done quickly. You would have gotten this done in 5 minutes. And it allows you to, when you take notes, you get through your chapter fast. And it's not so boring sitting and reading one word after the other, because you're engaging the paragraphs. So that's what I want you to do on this next page. I want you to read this paragraph, and I want you to take a short note of what this paragraph talks about. Then I want you to do the same with this paragraph. And then I want you to read this and then write down these math problems. Read it, take a little note, write the math problem down. Always remembering, when they're talking about Na, sodium has an atomic number of 23, go and double check on your periodic table. The atomic number's at the bottom right here, right above the name. Go ahead and compare it so that you put the words on this page into action, so you get your head wrapped around what's going on. It's very important that you understand this chapter so that you can do your classwork that you're going to be doing on your lesson in your JunoPod. Okay, if you have any questions, you let me know. This is how you do proper study skills when you're learning this information in chemistry. It is not as hard as your mind is trying to convince you it is. I promise you, if you take it one step at a time, one paragraph at a time, and take good notes, you will be successful in your lessons. If any of you have any questions, you can physically text me. If you need an immediate answer, you need to text me. Okay, I'm not looking at JunoPod every second of the day, but I'll have my phone on me. I understand this is difficult for some of you, but I promise you, if you take your time, you're going to understand this a lot better, and it's going to make it easier on you, okay? So I will talk to you later. Goodbye. Oh, by the way, look for that other video on the app that I'm going to be sending you. Bye-bye.